Hi everyone. In this video, I'm going to solve the first practical exam and hopefully you guys can see what errors to avoid and what you could have done differently, if anything. In the prac exam and in the assignments, reading specifications clearly is very important. Also because our prac exams are test-based, it's very important to take a look at the test data. Over here you can see on line number 19 that the statement is assert true all in one dot is not negative 5, which means that it expects all in one dot is not negative 5 to return the value true. And if it returns the value true, the test passes. You can see that 5 is not negative, 0 is not negative, 27 is not negative. On the other hand, minus 5 is negative, minus 1 is negative. Also, the maximum integer value plus 1 makes it a negative value, which is negative and therefore is not negative, should return false. In this case, we are checking that if n is more than or equal to 0, return true, otherwise return false. Otherwise means that n more than equal to 0 is false, therefore n is less than 0. If you go to the test and double click on the test name and run this, it passes the test and your score is 5. Let's say you make a mistake where you say if n is more than 0, return true, else return false, and I run the test again. Now you can see that there is an assertion error. And where is the assertion error? At test is not negative, line number 20. So if you double click on that error message, it takes you to the line for which the assertion error happens, which is line number 20. So you take a look at that. It says all in one dot is negative 0 should be true, which means 0 is not negative. And if there is an assertion error, it means that your method returned false. And you can see over here that it returns false for anything which is not more than 0. So we change that, go back to the test and run it again, and it passes. Next, to determine the parameters n, low and high, assume that low is less than or equal to high. Return true if n belongs to the range low comma high, inclusive on both sides. False otherwise. 20 belongs in the range 20 to 100. 100 also belongs in the range 20 to 100. 80 belongs in the range 20 to 100, but 19 does not belong in the range. You can do that in a couple of ways. You can either do that one at a time, where you check if n is less than low, then it does not belong to the range, you return false. If you come here, it means that n is more than equal to low. So you can check if n is more than high, in that case you return false. If it comes here, it means that n is more than equal to low and n is less than equal to high. And in that case, you can return true. We go back to the test, double click on the test and run this, and it passes. If you select all, or if you don't select a method name and run this, then the entire file executes and you can see both our tests pass. Now you can also change this code to simply saying return n more than equal to low and n less than equal to high. Now n more than equal to low and n less than equal to high is a Boolean expression, which is true only when n is between low and high. And it's false when n is not between low and high. So you can make your code compact as well, but for the time being, I suggest that you guys do this one step at a time. Method number 3, remainder. Now remainder What I'm going to do is I'm going to take a look at ITEC625 content development, lectures, variables, operators, and the PDF file. You can see that we have arithmetic operators, section 4, and clearly it says remainder is given by x remainder y. Some examples and exercises are provided as well for 13 remainder 5, 13 remainder minus 5, etc. And that's exactly what you have to apply here. And in this case, you need to return the remainder when n is divided by d. So it's n remainder d. Really, that's all. Go to the test, run it. You can now see that your score has become 15 because remainder has passed. Divisible by. Return true if n is divisible by d, false otherwise. So you can see that a number is divisible by another number when there is no remainder. In fact, I've actually given it over there. So all you have to check is if the remainder is 0, return true. In all of the cases, return false. Average. Now this is a slightly tricky method, but I have said over here that remember that int over int is int, while double over int is double, and similarly int over double is double as well. So if you return a plus b divided by 2, a plus b, because a and b are integers, a plus b is an integer, also 2 is an integer. So when I run this method, average, it will not pass. It expects 1.5, but the answer is 1.0 for this test here. So the average of 1 and 2 clearly should be 1.5, but your method returns 1.0. So you go to the method and see why it returns 1.0 when a is 1, b is 2. 1 plus 2 is 3, 3 over 2. And this is where it should click you that if both a and b are integers, it returns an integer. You can see that it's been provided in the lecture notes as well. If x and y are integers, the outcome is the integer part. Decimal part is discarded. Examples are a and b. A over b is 2, while c over b, because c is a double, over b is an int, it's 2.4. So that's the logic that you have to implement. You can either do that by casting a plus b to a double value before dividing by 2. When you run this, it now passes. Or if you don't want to do that, you can just, instead of 2, use 2.0, making it a double value. And it passes as well. Sum of all the odd numbers from low to high. Return the sum of all the odd numbers between low and high, including low and high. That is, all odd integers that are greater than or equal to low and less than or equal to high. If low is 4, high is 10, return 5 plus 7 plus 9, 21. So the first thing you have to check is low an odd number? And we do that by checking if low remainder 2 is not 0. If that's the case, let's say your starting point is this. If low remainder 2 is 0, starting point is low, Otherwise, starting point is low plus 1. You can see when low is 4, you start from 5. But if low is 3, you start from 3. So if low remainder 2 is not 0, my mistake? Oh, yep. So if low is an odd number, you start from low. Otherwise, you start from low plus 1. And your loop goes on as long as start is less than equal to high, have a variable total to store the sum of all the odd numbers. Total increases by that value, and start becomes start plus 2 because I want to move from 3 to 5, from 5 to 7, from 7 to 9. When the loop finishes, return total. You can also change the variable name start by choosing refactor, rename to current, which is a better name. Go back to the test, sum of odds, and it passes. Next, sum of squares. So adding all the squares from 1 to n. So it's 1 square plus 2 square plus 3 square till n square. Our total is 0. You have to go through each integer from 1 to n, including n. So that's our classic for loop. And each time total increases by the square of the current number, which is I square. When the loop finishes, we can return total. For confirmation, run the test, and it passes. Sum of the last two items. Read the specs carefully. Return the sum of the last two items of the array. If the array is empty, return 0. So the first thing we're going to check is the array empty? Is its length 0? You should also check if the array is null before accessing its length. If it's empty, return 0. Next thing is, if the array contains only one item, return the value of that item. So if data.length is 1, return the only item in the array, which is the first item, and therefore the last item. If the control comes here, it means that length of the array is at least 2. Your last item is indexed by data.length minus 1, and your second last item is indexed by data.length minus 2, and you return the sum of those two items. Let's take a look, and it passes. Next is return the number of times target exists in data. So we have to count occurrences, which means we need a variable. We have to go through each item in the array, which goes I equals 0, I less than data.length I plus plus. That's your array traversal loop. In the loop, you have access to the current item using data I. So you can check if data I, the current item, equals target. If that's the case, it means there is another instance of target, and you increment the count. You cannot return count immediately. It's only when the loop terminates and you've seen all the items that you return count. Checking if the array is in ascending order. Return true if the array is in ascending order, false otherwise. Ascending order is defined as an order where every item is more than or equal to the previous item. So you can see that we are accessing the current item, which we'll call array I, and the previous item is being accessed as well, which will be accessed by array indexed by I minus 1. Now because you're accessing I minus 1, you cannot start from I equals 0 because I minus 1 would be minus 1. So you start from the second item. So for example, if the array is 10, 70, 20, 90, you start from the second item 70 and check. In this case, 70 is more than 10, more than equal to. But does that mean that the array is sorted in ascending order? No, because there might be another item in front which might be less than 70, which is actually the case. So what we are actually doing is starting from 1 to the end of the array. If an item is less than the previous item, in this case you can see that 20 is less than 70, which means I don't care what's in front of it. I don't care, because 20 is less than 70, it violates the ascending order, and I can immediately return true. I cannot return false otherwise, so this would be wrong, because as soon as you find an item which is not less than the previous item, which happens in the case of 70 not being less than 10, it would immediately return false. Sorry, this should be false, this should be true. So if 70 is more than equal to 10, it will return true, which we don't want. It's only when the loop terminates and every pair has been checked are we sure that there are no violations and return true. Test in ascending and it passes. Count within distance. Read the specs carefully on this one. It says distinction level, so it's a bit more tricky than the previous ones. The parameter is data, target, and tolerance. Return true the number of items in array that are at most tolerance distance away from the target. So in this case, 10, 70, 20, 90, minus 60, and target is 50, tolerance is 30. Is 10 within 30 of 50? No. Is 70 within 30 of 50? Yes. So 1. 20? Yes, it's exactly 30 away from 50. 90? No. Minus 60? No. So we return true as there are two items that satisfy the criteria. We'll go through every item of the array because it's something that we need to count. We keep a variable in count. We can check if data I minus target is less than equal to tolerance. Now I'm deliberately making a mistake. Count plus plus. When the loop finishes, return count. So here I know there is a mistake. So let's run this with the mistake. And it fails. It says it expected 2, but the answer was 4. In what test? On line number 148, which is when you're counting within distance for the array A, target is 50 and distance is 10. So in this case, what we can do is we can put a breakpoint here and a breakpoint here. We can put a breakpoint in our method and I can debug my code. It goes into the debug mode. In the exam, I told students to remove timeout equals 500 if using the debugger. So I enter the debug mode and it's over here right now. And when I resume, it goes into the method. You can see that data is 20, 40, 60, 80, 30, 100. Target is 50. I equals 0. Data 0 is 20. Target is 50. 20 minus 50 is minus 30. Is minus 30 less than or equal to 10, which is tolerance? Yes. So count will become 1, which we didn't want to because 20 is not within 10 distance of 50, which exposes our mistake. So we stop execution, go back to the Java perspective and say that if math.absolute, so if the absolute value of this is less than or equal to tolerance, so it's on either side. When I run this, now the test passes. So if you don't know how to use the absolute method, you don't have to. You can also say if data I is more than target and this. Similarly, if data I is less than target, then you are checking the value target minus data I. So everything that you can do with built-in methods, you can do without them as well. And this test fails. So I made a mistake. This time it was not intentional. Expected 1 but was 0, where over here when we are checking A, 100 and 0. So you can see that I checked data I more than target and I checked data I less than target, but I didn't check data I less than equal to target. So I can change that to less than equal to, run my test and correct. So that's how you should debug your code. Next, insert into sorted region, left ascending. Again, it's a distinction level question. So in this case, you can assume that the array is sorted from index 0 to index minus 1. You can assume that the index is valid, and you're inserting the item array index into its rightful place. So if the index is 4, then you're trying to insert 20 in its rightful place in the region 0 to index. So in this case, 20 should belong between 10 and 30. Please know that the array is sorted between 0 and index minus 1. So what you can do is make a backup copy of the item at that index and start moving all items which are more than 8, which is more than 20, ahead. So we'll push 60, push 40, push 30, but not push 10. So as long as k is more than or equal to 0, which means there is a value there, and the item at that place is more than your backup value, array k plus 1 becomes array k. So we have moved that item forward, and k decreases to check the item before that. When the loop ends, it will either end because k became minus 1, in which case array k plus 1, which is array 0, becomes backup, or it will end because array k is not more than backup, which means in this case, for example, array 0 is not more than 20. So where should we put 20? At index 0? No, at index 0 plus 1. Now you can see that in both the cases, if else, it's the same statement, and therefore this statement becomes unconditional statement. That's insert into sorted region, and it passes. Next question is a high distinction question to check if when you merge two items, you get this array. It says over here you may add a helper method if you need one, and the method I'm going to use is count occurrences. Basically what I'm trying to say is that if the number of times an item exists in array 1 and array 2 combined is equal to the number of items that occurs in array 3, then yes, it is a merged array. Okay, so for each item in array 3, if we say C1 is count occurrences, let's say the item is array 3 index I, C1 is the number of times it occurs in array 1, C2 and C3 are the number of times it occurs in arrays 2 and 3. If C1 plus C2 is not equal to C3, we can immediately return false. Can I return true in the end? Not really, because if the first array contained 1000, let's take a look. We are going through array 3, right? How many times does 1 occur in array 3? 3 times. In array 1, 3 times, in array 2, 0 times. So 3 plus 0 is 3. The same thing happens for these ones as well. For 2, the number of times it occurs in array 1 is 0, in array 2 is 2, and in array 3 is 2. So 0 plus 2 is 2, and 0 plus 2 is 2. But what about this 1000? The 1000 doesn't occur, right? So once you do this for array 3, you also have to do it for array 1 and array 2. So make sure that each item in array 1 satisfies that condition as well, and each item in array 2 satisfies that condition as well. If you come to the end of it, it means there were no violations, and you can return true. Obviously, this is a very inefficient process. A more efficient process would be to sort the 3 arrays, then to combine array 1 and array 2 and compare with array 3. Anyways, let's run this right now and check if isMerged returns true, which is true. Now I can select all of them and run this, and they all pass, and the score is 100. So that was a walkthrough for the first prac exam. Hopefully you learned something that you didn't know earlier, and all the best for the second prac exam.